Alright, I've started on my new windmill turbine motor, which I'm going to use the cogwheel configuration instead of a windmill to turn this. But I bought this motor here. It's a LeBeau motor, and I took all the internal parts out of it right here. All these internal parts I removed from it, and I got this aluminum barrel that I hot glued or glued on neodymium 1/2-inch magnets. And see, what I can do is I'm going to take this and this is how it goes like that. I'm just going to take it like this and flip it like this, and it makes a perfect base for this barrel. See, and see, this will spin, or spins really nice. Got these. I'll push these closer together once I get my coils ready. See, here I have all my hand wound copper coils. I made 60 turns. I think this is 20 gauge wire or 18 gauge. Then I have this gizmo I made up to make the copper coils. So this is going to have 6 coils. 6 coils, and then I got this coffee can. I'm going to cut to the width of this copper coil to be my outer circumference of the casing that's going to go over the barrels here. So I'll take a hacksaw and cut this about that wide right there to set my coils on the outside, and then I may fiberglass a layer on the interior. See here? This here is I made these poles right here. They're going to be it's probably north, south, north, south, north, south, like that. North, south, and I push these together. See right here, I push these together, and this hub up here will hub up right here, and this hub will hub up right there, and it'll be a perfect fit to use my coffee can configuration on the outside of these. I have 6 of them, you know, and then these will spin, and I'll have you know, so I got my diodes. I'm going to need some 1N5822 diodes, you know, to make the configuration. I mean, to make 3-phase motor and a 35 volt 2200 UF capacitor to make the let's see, I have a diagram of that right here, how to hook these up on a 3-phase, you know, using this diode configuration right here, and this will be the output here, and I'll hook those up once I get everything in series. So that's looking good, sure enough. I mean, I'll get this together and get back with you. Okay, I got my coils, or my coffee can, cut to the right width, and I use these. Then I took a piece of paper and taped it around the outside with markings on it as to where to space, how far to space the coils. This will be my stator. And I use this level here to eyeball, using the string lines in here, how to hot glue the coils into the right place, so that yeah, see, then what I may do here is, once this is all done, is I'll make a sort of a mold in here, and then I can pour this outside perimeter with fiberglass. See, so what I'm going to do now is to make sure, to see if that'll fit, is I'm going to cut When I cut, see if the rotor fits into the stator. I'll cut these guidelines out with a pair of scissors and see, this is the back side of it there. It's all, and we'll see if this rotor is going to fit in there and see how much clearance I'm going to have. So it's really close as far as having enough room to be able to turn the rotor in there. So I think I'm going to be able to have enough clearance using this coffee can, see? So this should, yeah, this is gonna work. I probably have about a little less than a 1/4 inch of clearance on the copper coils. And that should do it. Maybe it's going to be a homemade stator from a coffee can, you know. And we'll see if it works. We'll get back with you after I hook it all up and get the wire connections all right. And we'll see. And this will go with my cogwheel design. I'm going to try this instead of buying a windmill. I'm just trying to see if I can make one that works. To see if I can use my cogwheel to spin up this rotor with the neodymium magnets on it and see what kind of current I can produce from it. Okay, back at the work table. Okay, I made the cradle, or the half sleeve attachment that I hot glued onto the base that holds the stator in place. And this is what I have so far on the, it turns pretty good. I got no resistance or nothing hitting the copper coils. The magnet's not hitting the copper coils. Here's the other end. And what I have to do here is, in here I have to make a drive shaft that I can either hook wind turbine fans up to, or a cogwheel, which is here, this cogwheel, or I can hook the cogwheel up to it to run the motor. I'm going to run the stator. And what I have to do here is to add a bearing and a cover plate for this, so I can add my bearing here. And what I did is I took a piece of copper tubing for my axle or my drive shaft that I had to cut up, hacksaw cut there and bend it down halfways or a little ways to fit over the indentation on the shaft. So this will be my drive shaft right here that I can either put a cogwheel on and run off the cogwheel design, or a windmill. So what I'm going to do here is I have to trace out my plate to be right there, using a pencil or a pen or something. Get this lined up here. That lined up. And what I'll do is I'll trace out the outer diameter on this plate. There's the line. I'll cut that on the scroll saw, and then I'll go ahead and, once I find the center, I'll put my bearing right about there, and then run my copper tubing through there, and then that will be my drive shaft. Okay, back at it. I got it. Got everything hooked up, bearings installed. And now we're just giving it a little paint. Make it match the casing or the frame of the induction motor casing. Yeah, I used it was had a little bit too much play in the bearing, so I put some electrical tape, wrapped it around the copper tubing to get it to so there would be no play in there, and that spins pretty good right there. Now I'll hook up either the cog wheel or this is the one I broke off of the first time I tried the alternator, but that may sit on there. May have to go to a bigger cog wheel if there's not enough power in the DC motor to spin it.